All right, this is video number 4, should be the last one. We're going to go through all of these questions right now. So this question. So you're testing a null hypothesis. That's what that H capital 0 means, null hypothesis. It states that the population mean is 4.3, whatever they're measuring. And it has an alternative hypothesis that says, no. The true population mean should be greater than 4.3, right? See that? So be careful. That greater than means an instruction. Because it's greater than, that means we're going to look something up in a table and subtract it from 1, because all the numbers in the table are set up for a less than, okay? But we'll worry about it when we get there. Okay, so that's what they're testing. Well, that doesn't really make any difference, except for, again, this greater than sign. But there's the z-score, right? Bam, 1.97. So we got to look up a z-score for 1.97. Here we go. Here we go, schmo. Okay, so z-tables. Let's just look up a z-table. So 1.97. 1.9, right? There's 1.9. There's the row of 1.9. And then we want the column of 0.7. There's 0.7, right? So I got that number, 0.9756. Everybody see that? That's at the junction, the intersection of 1.9 on the first column, and going row across the row, it's the 0.07 column, right? So the row and the column, you add them together. So 0.9756, but that's if it was less than. I'll say that again. That was if it was less than. We're dealing with a greater than. So we got to take that number, 0.95. Oh, I already forgot the damn thing. 9756. 9756. 9756. So I'm going to take the number 1, and I'm going to subtract 0.9756. That's going to be your p-value for that. It's 0.0244. There's your winner chicken dinner. Now, again, if that was a less than, then that 0.9576, whatever it was, would have been the right answer. But it's not less than, it's greater than, so you got to subtract it from 1. All right, part 2. You would not reject the null. We got to decide if that's true or false. At the 0.01 level, trying to show that the null does not equal 0, right? So, in other words, this makes it a two-tailed test because it's not equal to, with a test statistic of 266. Now, this is a lot harder to calculate. Just going to give you the short answer. This is false. You would reject it because a z-score or a t-score or a lot of these test statistics, if it's bigger than 2, you're going to reject the null. Because this basically, the z-score tells you how many standard deviations away one number is from another. And remember, the rule is 2. If 2 means are more than 2 standard deviations away from each other, that's considered significant. But let's go ahead and run this test anyway. I guess I shouldn't wig out on you here. Hold on. All right, for the not equal to hypotheses testing, again, that's a little bit harder. The good news is the software is going to do it for you. You don't have to go through this crap here, but I'm going to show you how to do it anyway. So for a two-tailed test, this is how it works. You find the p-value in here somewhere for the 2.66. And I'm sorry, was that the right number? Hold on a second. Yeah, 2.66 is the z-score. So what you do is you look up 2.66 on this table. There's 2.6. 2.6. 2.66666666. And there's the other 6 at the top of the row, right? 0.06. So what is that number? 0.9361. Is that right? Or is it 0.9961? Don't get old, you guys. Oh, it's 0.9961. So this is what you do. You take your 0.9961. Remember, that number would be if it was less than, but that's not what we're doing here. You subtract that from 1, so that would turn it into a greater than, And we don't care if it's positive or negative. Now, here comes the weird part, is you multiply by 2 because it's a two-tailed test. So there's your final p-value. Your final p-value is 0.00, I'm just going to round to 8. So your calculated p-value is 0.008, which is still less than 0.01, right? So again, if your calculated p-value, and ours is 0.008, is less than the critical alpha, this one they changed the critical alpha to 0.01. If your calculated p-value is less than the critical p-value, critical alpha, then you reject the null. So that's why, yes, you would reject the null, period. All right, next one. True or false? Calculated p-value. Again, I split up the p-values between calculated and critical. Critical means you're going to reject the null. Those are numbers you find in a book. Normally, the critical p-value is always 0.05. It also goes by the name of the critical alpha. It goes by many names depending on the book. All right, so we got a calculated p-value of 0.04, and the critical alpha is 0.05. Would you reject the null? Hell yeah, you would. You would reject the null because your calculated p-value is less than the critical p-value. Got it? Say that again. If the calculated p-value, that's the one you got to work for. It's the one you got to do all the math, get the test statistic, look up the p-value of that test statistic, and if that sucker is smaller than 0.05, you reject the null. Okay. Type 2 error. Type 2 error is where you do not reject the null when you should have. So does that fit this one? A type 2 error would be rejecting the null when it was actually true. No, that's a type 1 error. Type 1 error is where you reject the null when you're not supposed to, when the null is actually false. And that's the one we normally make. You know, as researchers, we always want to show something is significant, right? We're in a rush to show that something's significant. So if we reject the null when the null was actually true, that's a type 1 error. If we fail to reject the null when the null was actually false, that's a type 2 error. So this answer is false. And this one, a student tests negative for the swine flu when in reality she does have the flu, right? So it says that she doesn't have the flu when in reality she does have the flu. This is actually a type 2 error, right? It's a false negative, right? This other one was a false positive. This one's a false negative. So it showed that she didn't have it when in reality she did. So they should have rejected the null. The null states that she didn't have it in the first place. Remember, the null always states that, and there's nothing going on. Nobody has nothing. There's no relationships. There's no difference. So this is saying that the null was correct, but in reality she did have it, so they did not reject. So this is a type 2 error, so that's false. All right, here comes the good stuff. We use confidence intervals, believe it or not, to reject the null or not with these t-tests or these ANOVA tests, right? The difference between the means. So the rule of thumb is if you create a confidence interval for one group of where the true mean is and compare it to the confidence interval of a second group of where you think that mean is, and if they have any overlapping numbers, then you cannot reject the null because you think about it. The null states that there's no difference between the mean of group A or group B, and what that means is they would both have the same number somewhere in the confidence interval. So let's look. If we looked at this on a number line, 6.91 to 9.25, they do overlap, right? So from 6.91 is in this one, right, between 5.17 and 0.705. In fact, there's a lot of numbers. In fact, you might say an infinite set of numbers. So let's say the real mean was 7, right? 7 is in this confidence interval. 7 is in this confidence interval. So you would not reject the null hypothesis, right? So would you reject the null hypothesis? No, because their confidence intervals overlap. So the next ones are just like that. So the first sample is confidence interval low of 12.65, high of 15.44, and the other one is 17. Now they don't overlap, right? So this lowest number here is 17. The highest number is 15. So they don't overlap, so you would reject the null. So this one you would reject. All right, next to the last. So this is the difference between two means. You see that? This is a confidence interval for the difference of two means. So if you're looking at a confidence interval for the difference of two means, I can't say that enough. Difference of two means is different than the ones we just did. This is the difference of two means. If there's a 0 in a confidence interval for the difference of two means, you cannot reject the null. So you'll notice 0 is not between negative 3.16 and negative 0.84, right? The 0 is not in that thing, so you would reject the null. All right, last one. So this is the difference of the means again. Now you notice that 0 is in there, right? 0 is between negative 1.69 and 0.78. And so and 0 is right in there. And that's what the null states. The null states that the difference between the two means is 0. So you would not reject on this one. You would reject on this one. And that's the name of the game. And that's it. Okay, I hope this helps. MGZ out.